has played a critical role in history, an invention which has been praised and denounced, served hero and villain alike, and carries with it moral responsibility. To understand the gun is to better understand history. It is forged from simple raw materials, but is so durable it can last more than 100 years. It has few moving parts, but its design requires complex engineering. Its purpose is basic, but it is one of the most powerful and destructive devices ever created: the making of a gun. In an unassuming factory outside of Washington, D.C., one of the world's most popular handguns is made. Tens of thousands of Beretta 9mm are purchased every year by the United States military and police departments. And though computers now do many of the tasks required to make a gun, the process mirrors procedures forged in the hearts of gunsmiths centuries ago.
Ever since the invention of guns, people have been fascinated by this handheld object that is a combination of art and craftsmanship, history, mechanics, romance. Without the gun, where would America be today? We might be making Indian baskets. Maybe the British would still be ruling us. The gun has more fascination, at least in my experience, than any object ever made by the hands of man.
For those whose lives depend on guns, knowing that strict tolerances are adhered to on the production line brings peace of mind.
If it gets down to gunplay, if it gets down to deadly force, then that's the way it has to be. And that's when I need the gun, and that's when I need to know, without any question, that that gun is going to work.
The making of guns and making them work helped revolutionize American society. The firearms industry was one of the first to use computer-aided design. Early gun makers were the first to use interchangeable parts, a radical improvement over previous technology. And guns were the first mass-produced item in the world. Knowledge developed from making guns forever changed how all businesses manufactured goods.
We often think about Henry Ford as being the father of mass production. But in point of fact, the first 2 years of production at Henry Ford's Highland Park plant didn't equal the output of the Springfield Armory in the midst of the Civil War.
But it was some 400 years before the American Civil War that the making of a gun was first attempted.
The first gun looks like a vase, and there's an arrow in it. And there would be a small touch hole in that and the powder inside, and when you ignite the powder, the arrow flies out.
But the crude early attempts were riddled with flaws. A gun rarely worked, and often wounded or killed the person trying to use it. The design was quickly replaced by the ancestor of today's firearm, the hand cannon, the little brother of the field artillery used at the time. Not much is known about who developed the hand cannon and how, but the end result was much more effective than earlier attempts to make a gun. Heated wires were placed into the back of the tube to ignite the charge. Though rudimentary, the hand cannon was able to fire. The first version of the modern gun was born. Nearly 2 centuries later, in the fledgling colonies of America, blacksmiths were busy retooling their workshops to deal with the increasing need for guns. The firearms industry was busy experimenting with new types of materials and production styles. But making gun parts, such as the barrel, was still a time-consuming process.
these gun barrels were initially all hand forged over anvils. And what you had was a ruler of iron about 3 feet long and about maybe three inches wide, and you had to heat that ruler of iron to a red heat until literally the middle turned red. And then you had to shape that with a hammer over an anvil to round it over a bic iron, which is a tube that you kind of inserted so the thing didn't close up on itself. But you literally shaped this through numerous heats until you had a completed tube, and basically in the shape of a barrel. It was a long process. It was a very difficult process. It required a great deal of skill.
In an era filled with wars and revolution, those who knew how to make guns were in great demand. Though blacksmiths had many of the skills needed to make an early gun, other trades also got involved.
One of the things that's interesting about this business is that we often think that one gunsmith made the entire gun. But in point of fact, the more aggressive and more successful gunsmiths often bought parts. For example, by the 1790s, early 1800s, there were individual shops around that just specialized in making gun barrels, as there were shops in England which manufactured firing mechanisms or gun locks and sent them to the United States. In fact, it's very rare to look at a firearm made in the United States around 1800 by a small shop artisan and not find pieces on them that were made by other groups. I think it's correct to think of early American firearms as being art objects. They're beautiful in many ways. They reveal a degree of workmanship that's unparalleled in most other areas of craft, because a gunsmith had to be a worker in iron, had to be a woodworker, also had to be a brazier, working with brass, and oftentimes had to be an engraver.
But there were flaws inherent in early guns. Because of inconsistent forging techniques, barrels would sometimes fail when fired, often in the face of the person pulling the trigger.
Unfortunately, in those days, it was hard to tell whether you had a good barrel or a bad barrel until you proof tested it. You take it out on the grounds and put about 4 charges of gunpowder in it and light it off to see if it would stand those charges.
There were other problems as well. It took gunsmiths up to 1 month to make a single gun. The price was prohibitive. Construction costs of a standard military musket in the late 1700s were between $13 and $15. A considerable sum of money for the time and place.
If you were to look at the wages, say, of an ordinary working person at that time, say a farmer, I doubt very much that many farmers were making $15 a month in their wages. So if you were to compare the price of a musket with the price of what people were earning at the time, you find out very quickly they're very expensive.
One reason weapons cost so much was that each gun was unique. There were no interchangeable parts. This was a major drawback. If a part on a gun broke, such as the firing mechanism, a new firing system would have to be constructed specially for that gun. It was a time-consuming and frustrating experience, especially for soldiers fighting on the battlefields of the American Revolution.
Imagine a battle, and a part on a gun breaks, for whatever reason. Perhaps it's the hammer that snaps. Perhaps it's one of the springs inside of the lock plate. That rifle is absolutely out of commission. Now, a gunsmith or an armorer would travel with a regiment. We're talking about a primitive operation, a little fort set up, a couple of hammers, some files, and this armorer is trying like mad to repair or to make a new part to make that weapon serviceable again.
The quest for interchangeable parts began in earnest after the war. In the 1820s, inventor Eli Whitney set out to streamline the process of making a gun. Best known as the creator of the cotton gin, Whitney also held hundreds of other patents that helped improve industrial production in the early 1800s. One of the businesses Whitney went into was gun making. The federal government gave him an order for 10,000 muskets that had to be completed quickly. It was an order that even the self-assured Whitney knew would take years to fill. He would have to find a way to mass-produce the guns in order to make his deadline. And in order to mass-produce guns, he would have to make identical, interchangeable parts. That was something that had eluded gun makers for centuries.
He had difficulty meeting this contract, and in order to cover up the fact that there were these significant delays, he said that he was trying to perfect a system of mass production and parts interchangeability.
Whitney knew if a weapon could be developed in which parts were easily exchanged, the making of guns would never be the same. When Whitney's delivery of muskets was delayed, he said it was because he was busy refining the nation's first gun made with interchangeable parts. To prove his claim, he invited government representatives to his factory to see for themselves. He took several of his guns apart,
and he mixed them all together and then proceeded to put together several locks. The fact is, this is something that he had prearranged. If he had been asked to do this with any one of his guns, he would not have been able to do it.
Whitney in his own lifetime never did really achieve it, and the easiest way to tell that is to get a hold of some of Whitney-made muskets from, say, his first contract and disassemble them, and you'll find out very quickly that those parts are just not interchangeable.
Whitney eventually delivered his guns, but his quest for interchangeable parts had failed. It would be another 30 years before a trio of gunsmiths from a small town in Vermont would discover the secret to interchangeability and revolutionize the world. During the early 1800s, vast improvements in manufacturing were being made in the United States. No industry saw more rapid change than the business of making guns. Many weapons made during early American history were considered works of art, adorned with brass, ivory, and fine engravings.
It was not uncommon in the late 18th, early 19th centuries to find guns that were very heavily embellished with silver and brass inlays. Some guns, I've even seen a gun, interestingly, the barrel was made by a guy named J. Christ, who was a barrel maker down around Lancaster, Pennsylvania, who evidently did nothing else except make barrels. This particular gun had not only brass and silver inlays on it, but it also had ivory inlays on it. It looked like it was almost made in Arabia or somewhere like that. It looked very almost un-American in its decoration, and yet it is a Lancaster County-made firearm.
But gun buyers still had to deal with the lack of interchangeable parts. If just one part on a gun broke, the weapon was rendered useless. Gun makers knew that if firearms could be made with exchangeable parts, guns could be mass-produced, a step that would forever change the industry. Though some designers had limited success, none could create machines with the intricate tolerances required to consistently make gun parts the same size. But all that changed during the early 1840s in the small hamlet of Windsor, Vermont. There, a trio of businessmen, Nick Kendall, Richard Robbins, and Samuel Lawrence, had an idea. They wanted to use the river that ran through town to power machine tools. The three men incorporated the river's energy with their ideas of mass production. The result was some of the world's first automated gun-making machines. Machines that made gun parts the same size over and over again.
Well, the secret was, let's begin to use some of these new machine tools that are starting to show up. Machines that could now begin at least to cut the contour of the stock of a rifle so that you didn't have to carve it by hand. Simple milling machines that could begin to form a lock plate for a rifle. A simple lathe that might be able now to turn a barrel instead of forging a barrel.
The company experimented with new designs as well. Nick Kendall developed a different position for a firing hammer thanks to the dress of his bride-to-be.
The story goes that Nicanor Kendall was out in his buggy with his fiancée. And of course, those days you carried your rifle with you in the buggy. And you're out in the countryside looking around, beautiful day. Some critter crosses the road in front of him. Kendall reaches down, grabs his rifle, pulls it up to his shoulder to take a shot. In the process of lifting his rifle, the hammer gets caught in his fiancée's petticoat. Just enough to pull it back, it snaps forward, the gun discharges. Kendall feels this terrible burn. He's sure that the bullet's gone right through his hand and it's killed his fiancée. By the time the smoke clears, he realizes, no, he just got a small powder burn, and his fiancée, thank heavens, was fine. That led Kendall then to come back to his shop, begin to putter around, and develop the underhammer, so that there would be no danger of the hammer getting caught on somebody's petticoat.
By 1843, after years of trial and error, the firm had finally perfected machine tools that adhered to tolerances needed to make interchangeable gun parts. They received a government contract to produce 10,000 rifles. The faster they made the guns, the more money they made. It was great incentive.
The technology all comes together. And these 10,000 rifles they produce for the government, every nut, bolt, and screw, every component part is interchangeable one gun to the next. And not with any sloppiness in the tolerances, but beautiful, fine fit and finish. The government's thrilled. I mean, they finally have got interchangeability, this quest they'd been after for so many years.
The moment marked the beginning of a manufacturing revolution. Other gun-making firms, including the government's own armories in Springfield, Massachusetts and Harpers Ferry, West Virginia, quickly followed suit.
It's the period between 1815 and 1864 that you begin to see the germination of this new technology that's based on the introduction of machine tools and the introduction of precision measuring devices that culminates in this tremendous production that takes place, and not just at the Springfield Armory, it's the entire American firearms industry.
Kendall, Robbins, and Lawrence continued to lead the field. In 1851, they traveled to London to display their guns at the Crystal Palace World Exhibition.
Now, their display consisted of nothing more than taking 6 of these Mississippi rifles over there, disassembling them, scrambling the parts around, and then reassembling them. The British went berserk. They couldn't do that. The only analogy would be the reaction that we had back when the Russians launched Sputnik.
Kendall, Robbins, and Lawrence agreed to make guns for the British. When the Crimean War broke out in 1853, they were given an order to produce 25,000 Enfield mini rifles at a cost of $25 each. Once finished with that, there would be another order for 60,000 additional rifles. The contract contained a penalty clause if the firm didn't deliver on time.
It was like a black cloud. Everything imaginable that could go wrong with the production of these guns goes wrong. Really silly things, like the wood for the stocks of these Enfield rifles came from Pennsylvania. There's a drought. All the little sawmills shut down. They can't get any wood for the stocks for a whole summer. The gauges that they requested be sent over from England were made out of hardwood, and on the sea voyage over, they split open. Robbins and Lawrence had to make their own set of steel gauges. So it was one delay after the other.
By the time the Crimean War ended in 1856, Kendall, Robbins, and Lawrence had delivered only 14,000 rifles of the initial order. The British government sued. The company went bankrupt, and in order to satisfy creditors, the firm's factory became property of the English Crown. Ironically, one of the most innovative gun manufacturers had been put out of business on the eve of the most concentrated push toward mass production of guns the world had ever seen, the American Civil War. No matter how they may have felt politically, on the eve of the American Civil War, gun manufacturers, both North and South, knew they were in for a financial bonanza. The only problem was how to keep up with demand. The makers of firearms began experimenting with new ways to make guns faster and cheaper.
A firearm made in 1864, compared with a firearm made in 1815, was qualitatively a much better gun, primarily because there were fewer possibilities of failure. Barrels were not going to blow up as often as you would have had in 1815. Technologies had improved to the point that, you just had fewer failures of parts than you had in that earlier period.
The result was the most efficient system of manufacture yet in history of any product, and it was the gun makers who led the way. There were craftsmen who were not only inventing, but had developed machine shops that were so good that some of the products they made cannot be equaled in quality even today.
Experts who study guns from the Civil War era believe those weapons were of such high quality that the ones that failed did so because of soldier error.
In the heat of fighting, people had the tendency of loading their gun with powder and ball and then forgetting to put powder or a cap on the firing mechanism, so they would pull the trigger and the hammer would go down and they think they fired the gun, but nothing went off, and then they'd load it again, and this time they put the cap on and fired, and of course they had a double charge and then the gun would blow up.
In 1862, the Vermont factory made famous by Kendall, Robbins, and Lawrence 20 years earlier was purchased from the British by a man named Ebenezer Lamson.
Lamson walks in. All the Robbins and Lawrence machine tools are still in place, all tooled up still to make component parts for this Enfield rifle. And Lamson looks at this setup, and he says to himself, my gosh, I can make a variant of this Enfield cheaper and more efficiently. I'm going to get rid of the brass hardware, that beautiful brass butt plate and trigger guard. Brass is expensive. I'm going to substitute steel. I'm going to get rid of that very sophisticated tangent sight on the Enfield and substitute a simple leaf sight. Why are there clips holding the barrel bands in place? That's a complicated operation. Cut out the wood, make these clips, insert them. Get rid of the clips, we'll substitute screws. So with some very simple changes like that, he in essence comes up with a new weapon, the Model 1861 Special Rifle Musket. He produces 50,000 of them.
Such changes in technology, like Lamson's, had a huge effect on the battlefield. Soldiers had to adjust to lightweight weapons that could do much more damage. Better materials and engineering had made guns more lethal.
The population of Vermont has never recovered since the Civil War. Many, many men lost their lives in battle during the Civil War. A lot of that loss of life is because of the change of technology in firearms.
Huge orders for guns became common during the war. Factories struggled to keep pace. Raw materials such as steel and wood became as valuable as food. The gun manufacturers of the North, especially the armories at Springfield and Harper's Ferry, became the nation's first centers of mass production. But the logistics of shipping raw materials to firearms manufacturing plants, especially during wartime, was a tremendous challenge. Railroad lines became vital links. Materials were shipped by the trainload to gun-making plants. Within days, crates of rifles and pistols were on their way to the front. It was a 24-hour-a-day operation.
The Civil War is a period of big change in gun making, because it's a time that witnesses the manufacture of firearms in very, very large quantities. The Springfield Armory, which is one of the two national armories in the United States at that time, by 1864 was manufacturing well over 250,000 rifle muskets a year.
Increased productivity brought opportunity. As one model of gun was tested on the battlefield, the next generation of design evolved from its predecessor's mistakes. Firing farther and faster was the battle cry of gun manufacturers. technology improved more during the 4 years of the American Civil War than in any other time period in the history of the gun.
It changed the course of the way battle was done. It changed the way that guns were made, and it increased the ability to kill dramatically. Imagine that at the beginning of the Civil War, some regiments were going into battle still carrying smoothbore, flintlock muskets left over from the Revolutionary War period. By the end of the Civil War, the repeater is developed. The cartridge, the modern cartridge, exactly the same as we use today, has been invented. Even the principle of the machine gun, the Gatling gun, had been laid out. So all of this happens just during the period of the Civil War. A technological change in firearms that is probably as dramatic as the technological changes that we're seeing with computers today.
No sooner had manufacturers perfected their ability to mass produce finely made handguns and rifles than the war ended. With no battles to fight, the government no longer needed hundreds of thousands of new guns every year. Except for a handful of major manufacturers, the firearms industry withered and all but died. The Kendall Robbins and Lawrence factory in Vermont, which had supplied guns to the Union during the war, was refitted to make sewing machines. The Remington Firearms Company, which made rifles and revolvers, retooled its gun-making machines and later made typewriters. The bounty of weapons that had been produced during the war went home with the soldiers.
Well, one of the interesting side effects, I think, or after effects of the Civil War was the enormous number of firearms that entered the general population after the war ended. There's been a lot of new research on what happened to the guns that Union soldiers were carrying during the Civil War, and the answer is that they were allowed to carry their guns home. And of course, this meant that hundreds of thousands of new firearms entered the general population, whereas they hadn't been there before, or at least not in those numbers. The United States in 1865 was probably the most heavily armed society in the world at that point because of that phenomenon.
The lessons learned during the Civil War propelled gun manufacturing well into the 20th century. American gun makers continued to push the limits of new technology. Stronger metals were used to make guns lighter and more durable. Improvements in gunpowder and bullets helped make firearms more lethal from longer distances. The gun-making expertise of U.S. firearms makers caught the attention of foreign governments, and the United States became the world's top exporter of guns.
Americans selling to a lot of people, Americans tooling the armories of other people making better guns and driving Americans out of those markets, and then, it's almost as if the beginning of World War I began with the end of the Civil War.
During World War I and World War II, guns were the ultimate item of mass production. A machine tool factory could be refitted in less than a week and have firearms pouring off the assembly line. Changes in gun design allowed firearms to fire faster with more killing power, and the pace of manufacturing had drastically accelerated. But the process continued to be cyclical. Every time the world geared up for war, firearms manufacturers were able to meet the demand. Hundreds of thousands of people would be put on the assembly line. Millions of weapons would be pumped into the war machines. As wars ended, gun production would drop dramatically. Factories would again return to making consumer goods like radios and televisions, employing the same production techniques used to make guns for the military. But another revolution was just around the corner. It would be the biggest transformation since interchangeable parts. The computer was about to take a shot at the making of a gun. At the Beretta manufacturing plant outside of Washington, D.C., the computer has become a key component in the making of a gun.
This is a completely computer-controlled machine, including the rotation of the fourth axis. In this case, all we're doing is loading a program just like you load a disk on your PC at home. We load a program that tells the machine exactly which tools to put in, which cuts to make, in which sequence. It'll rotate the part and reposition it for the new tool. It'll change tools during its cycle and make multiple cuts. In the old days, we probably would have had 7, 8, 10, or even 20 different machines making each one of the cuts individually and reloading the part in and out of the machine every time. In this case, we can load it one time. We can make multiple cuts in multiple directions. I can walk away and just let it happen by itself.
200 years ago, making this one handgun would have taken a gunsmith more than a month. Computer-aided manufacturing has the process down to a few hours.
This is a special drilling machine that was designed specifically for the manufacture of the 92-96. And as you can see, it's doing multiple drilling operations simultaneously. We load one part into the fixture, and we're drilling and reaming holes from the front, from both sides, all at the same time. When we take a part out, we may have done what it used to take in the old days, 7 or 8 drill presses in a line, all in one operation in roughly the same amount of time that it took to do one. Now we're doing 7 or 8 of them in that same period of time.
Beretta is the oldest gun manufacturing company in the world. It was founded in the late 1600s in Italy. 14 generations later, the Beretta family still maintains tight control over their product. Beretta is famous for its 9mm pistol, which sells for $600.
One of the most extraordinary firearms ever made is this Beretta Model 92 FS automatic pistol. This was designed in the 1980s and was adopted by the U.S. government for all its armed services. It has been adopted by over 2,000 police forces and armies all over the world. It represents the ultimate evolution of the semi-automatic. It fires a 9mm cartridge. It holds approximately 15 rounds in the staggered magazine. The way it functions is the slide is pulled back, and when it is released with this thumb lever, it picks up the cartridge from the top of the magazine. And when it is ready to fire, you simply pull the trigger, and the entire process is repeated very quickly. It has an ambidextrous safety, which means it can be set from this side or this side. And when it's pushed down like that, the hammer falls and does not hit the firing pin. Another sophisticated detail of this pistol. There are so many features on this pistol that it would take about 20 minutes to explain them all.
The making of a 9mm Beretta begins with simple raw materials. A block of aluminum, which helps keep the gun light, is cut and molded into the framework that will become a handgun. The frame is drilled and grinded according to specifications in the gun's computer-aided design. Before the slide can be fitted with the barrel, it must be checked for tolerances. The computer makes sure the job is done right.
Here we have an in-process inspection completely controlled by the computer. You can see on the screen all the dimensional characteristics that we're going to check on the part, and the computer will actually check the part when we load it in the fixture, and the screen will actually light up with red and green whether it's good or it's out of tolerance.
The manufacturing of a firearm requires very tight tolerancing. We here manufacture everything in millimeters, and we're measuring things in thousandths of a millimeter. Just to give you an example of what that might be, if I were to pull a hair out of my head and split it in about 5 pieces, one of those pieces could be equivalent to the tolerance that will hold, for example, on the overall headspace length of a barrel.
Despite all the high-tech gloss and machinery, much of the work done at the Beretta factory mirrors the gun making of decades or even centuries ago.
The unique factor that we have here is the fact that all of these parts are interchangeable. Any receiver, any small parts, no filing, no fitting, they're all interchangeable. We can put any components in.
The only thing that has changed is the speed and accuracy with which guns can now be produced. Even in the computer age, the century-old desire for interchangeable parts is still a concern.
When we do an interchangeability test here at Beretta, we pull a pistol completely apart. We take 10 pistols apart after they've been completely tested. We mix all the parts up, put them back together in some other 10 configurations of pistols, and then we expect the same testing results and pass all of the same testing criteria for those that we had when we started.
Once the gun passes tolerance and interchangeability tests, it goes to the polishers, who grind down any minor imperfections left in the weapon's finish.
Some of the parts are built using computer numerically controlled machinery, but at the same time there is a certain amount of hand labor that's necessary. But then there's enough hand filing, there's enough hand fitting. So at one point you're going to be watching gunsmiths sitting at a bench the old-fashioned traditional way, but they work so fast their hands are a blur. And bingo, they've got the gun assembled and it's ready to be test fired.
Before any gun made at the Beretta factory is delivered, it must be test fired for durability and accuracy. An operator bolts the gun into place, sets the sights for a target 25 yards downrange, loads the weapon, and stands aside while pulling the trigger, thus ensuring that the factor of human error is eliminated.
Every pistol that we manufacture at Beretta, either in the U.S. or in Italy, all of our pistols, all of our shotguns, and all of our rifles are all test-fired at the plant. They're proof-tested to make sure that they will withstand 130 to 140% of pressure of standard ammunition. And then they're function-tested to make sure that they function correctly. And then all of our weapons are also tested for targeting and accuracy.
The guns are then packaged and shipped to military arsenals and gun shops around the world. Officials at Beretta believe their weapons are some of the finest mass-produced products in history.
Maintaining that quality level in the firearms business is set by the ownership of the companies. In our case at Beretta, it's always been family-owned. There are Berettas, and the Berettas are the people who run the company, and they expect that standard. They've kept this company going on for 13 or 14 generations, and you don't do that by setting low standards on quality or not producing good products or believing that you manufacture a product that's made for a lifetime.
The final step in the making of a gun doesn't happen in a factory at all. It comes when the gun is pulled from its wrappings and placed in the hands of the people who rely on them most, the police and the military. In the nearly 500 years of firearms manufacturing, the final step in the making of a gun has come not at the factory, but when the gun buyer pulls the trigger. David Mackenzie has one of the toughest jobs in law enforcement. As a police officer in the Washington, D.C. area, he's assigned to hunt down fugitives wanted on arrest warrants. He carries a gun with him 24 hours a day.
To be perfectly honest with you, I've been carrying a gun so long I can't remember what it was like not to. It's very second nature. Some of the situations that I get into, I would not want to be in without a gun. The only time I really think about having the gun on is when stuff starts to go south.
A well-made gun is an absolute necessity for Mackenzie to do his job. When he shops for a gun, whether it's for sport or for work, he approaches the purchase like a gunsmith. Is the gun well made? Does it meet the standards expected by a serious gun maker?
You want to check the lock mechanism on it, make sure it locks up properly, make sure it's aligned properly. You need to know what kind of barrel is on it, what kind of twist there is in a barrel. I start messing around with the trigger to see what kind of trigger pull it had. When I'm looking for a gun, I usually try to get one from somebody that I know. I know a lot of people in the business. I know a lot of people in the craft. More often than not, especially an old guy in an old gun store, he's going to know an awful lot more about that weapon than you do going in.
Gun manufacturers recognize that their product is essential to police officers like Mackenzie.
The most critical thing to law enforcement is when they pull that weapon out, they have to feel comfortable and depend that that weapon is going to do what it's intended to do. It's their life on the line at the point where they need to pull that weapon and use it. So reliability and the durability of the weapon is very important in law enforcement.
My primary concern for police officers is that they go home at night. If you need to pull your gun out in the line of duty, then you shouldn't really be bashful about doing it.
But law enforcement and the military are not the only places where the making of a gun ends. A large segment of the population owns guns. Many purchase weapons for sports shooting and collecting. Those familiar with the history of guns say firearms made by modern gun manufacturers today have reached near perfection.
Gun making today is an unusual combination of the old and the new. The demand by the customer to have a very high caliber, high quality firearm is probably more intense now than it has ever been in history. The capability of the industry to manufacture perfect guns is at a status that has never been achieved in any of the 500-year history of gun making.
As gun-making technology improved, the ability of gun buyers to spot poorly made guns has increased.
A crude gun is a crude gun whether it was made 150 years ago or made today, and a beautiful gun is a beautiful gun whether it was made 150 years ago or today. You enjoy them on their own merits.
Today, the making of a gun is considered a marvel of manufacturing, not because a gun is a sophisticated piece of equipment, but because it is a product that is built to last a lifetime.
People take pride in owning firearms. And most people take care of them. I mean, they clean them and they put them away, and they don't just throw them in the corner of a closet or mishandle it the way they might in other products. So I think there's a little bit of pride of ownership there in the way that they take care of it. In a lot of families, it's a big deal as to who's going to get Dad's gun when he doesn't want it anymore.
Regardless of how people feel about the making of guns, the influence of guns on society has been deeply felt and profound.
We're not revisionists here. We don't want to change history to make it sound right for the right person. This is a fact. The lifestyle you enjoy today is possible because of the machine tool. The leisure time you have today to pursue education, to do whatever you wish, is because of mass production. The machine tool makes that possible. What led to the evolution of the machine tool? It was the gun.
For those who find beauty in the handcrafted workmanship of a well-made gun, the firearm is a thing at which to marvel.
There are millions of people who want guns. They're not only the governments that need them for their defense industry, but there are hobbyists of all kinds. Most gun makers want to be at the forefront of technology, and I think that it's anybody's guess where it's going to go, but the one thing is for sure, quality gun making is something that is here forever.
Some would like to see gun manufacturing shut down altogether. Others believe the world would be a safer place if every person owned a gun. The debate over the future of the industry is far from over.
People are raised up with guns and just feel more comfortable with them. Many people who live in urban areas oftentimes have never even seen a gun before, let alone seen one fired, and are scared to death. And for good reason. They're dangerous things. And if you're not acquainted with how something works and not acquainted with the practice of using these things safely, then you have good reason to be worried about firearms.
It is a process forged from ingenuity, raw materials, and fire. It has changed the world for the better and for the worse. all the power and destruction mankind has ever created still remains in the making of a gun.